Hello, welcome to this video and thank you for watching. I wanted to give a fairly short introduction to LUA programming within EEP. EEP is a software program that allows you to create basically model railways or virtual real railways and then operate and run those layouts, those railways within the EEP program. It's a great little program, got lots of potential for further development, but the current version is version 13, which is what I'm running, but from I think version 10, I didn't have EEP in those days, but from version 10 the developers provided users with the ability to write short script programs in a language called LUA. Not sure how you pronounce it, I pronounce it as LUA. I'll carry on using that name until someone tells me otherwise, but please feel free to correct me if there's a better pronunciation. Anyway, within EEP you can write a LUA program that can control, manage, interact with your railway layout and perform various functions. The current interface, the current API and the functions that are available for the LUA code is very limited and does need some dramatic improvement, but it allows you to do some basic functions, and you can actually, even with that, achieve quite a lot. I've uploaded a separate video. Once I realized you had this capability within EEP, I thought, okay, great, I can quickly knock together a complete track management control system. Won't take me long, and I can knock that together so that whatever layout I create, no matter how complex, no matter how many trains, I can control it within LUA, so that I can then just sit back and enjoy my layout with the LUA program taking care of all the signalling, track control and everything else. It proved to be slightly more complicated than I originally anticipated, but I have got a first version working and I've uploaded a video. I'll give a link to that below in the description. But the main problems were LUA is quite a simple language. Got to grips with that very quickly, very easily. It's a very simple language to learn. There's a couple of minor issues that you need to take note of, but I underestimated exactly the complexities of managing a railway from a software control system and some of the signalling issues, so that was slightly more complicated than I originally anticipated, but was fairly achievable. And there's the limitations within the present API, the present range of functions that are available, and the fact that within EEP there's not a debugger and there isn't a proper code editor. So they all represented little challenges, but I've currently got an initial version of my control system working. As I say, there's a video link below that gives a quick intro to that. Within this video, I did think about creating a set of tutorial videos explaining LUA programming within EEP to try and help other people with how to program within LUA. If you have some comments, if you'd find that useful, if you've got some suggestions for what you'd like covered, please leave me a comment. I'll answer any questions if I can. This basically is just an introduction and a very quick overview. I will try and do a far more structured set of tutorials once I've thought through exactly how best to do that. So, going ahead with this introduction, what I've done is just created a new layout, very simply created a simple oval track. Just one comment before I get into the LUA side of things. Within program settings within EEP, there is two fairly useful little options. One, actually I'm running this screen at fairly high res, so if I bring a Windows magnifier, this is not part of EEP. Before you start going, hang on, how do I get my EEP to do that? It doesn't. This is just a Windows tool that provides a magnifier. This screen's at fairly high resolution. I'm running several screens on this system, so it's useful just to have that magnifier to help make the YouTube videos a bit more readable. Anyway, on the options within the program settings, there is a tick box for undock Windows. There is a further tick box for EEP event window. If you're going to do EEP programming in LUA programming within EEP, both of those are fairly useful, particularly if you are running multiple screens. So what undock Windows does is you'll have in 3D mode, I'll get rid of this magnifier for a moment, and I will bring in from the other screens the windows that you have. So a standard EEP has these different windows, and there's a code editor. Basically, if you click undock on that settings panel, then you can move these different little windows into other screens, which is really useful. It then leaves your main screen just displaying your track, and it is really good if you have multiple screens. And I'll bring the magnifier back in. So bring the control dialog back in. Within this simple layout, you have a text editor here. It isn't really a code editor. It says it's a script editor, but it's basically a very simple text editor. What I find useful is to use Notepad++, which is a free open source program. I'll provide a link below. You can download it, and that allows you to edit your code in a more fully functioned code editor. Within Notepad++, there is some support for LUA, so you can select LUA, and then you can collapse functions. If you, for example, double click on a variable, it will highlight all of the instances of that variable. There isn't really any syntax checking, but at least you've got a bit more full-functioned code editor if you're going to write anything other than some very simple few lines of code. To go between Notepad++ and your EEP program, all you need to do is save as, give files a .lua suffix, save them, and then in EEP you can, if you go to the top and click the little page icon to go to the LUA editor, you can then load your script and select a LUA file that you've saved from Notepad, click open, and it will load it in here. So this is the actual code for my full track management system. At the moment it's 1500 lines long, so that gives you an idea of the complexity of it, but also you can achieve quite a lot even given the limitations of the current LUA function set that's available. So I will cover a sort of few basics in this video. I'll just move that to one side for a second. LUA code. LUA code is based around functions. You declare a function quite simply, function space, function name, open brackets, parameter list. So if I wanted to create a function, my function P1, P2, P3, and functions terminate with an end. Quite a simple syntax. And in LUA, variables are not declared as specific types. So for example, if I have a variable a, I can assign it 0 here, but a few lines further on I can say a is now a string, and a bit further on I can say it's a table 1, 2. So all variables are dynamically typed. You can assign them to be whatever you want. There are only, I think it's 4 basic types of variable within LUA. There is number, there is string, table, and null. So I can set a now to nil. That's it. You can change what type of data is represented, and it's a very simple language. There's limited syntax and checking. So one issue comes about because of scoping. By default, LUA variables are global. So if I have a variable that I declare in this function, variable a, and in a later function I say a equals 10, and if somewhere in here I call that function, so it's called train contact 3, then that function changes my global variable a, and therefore it will modify a within this function. So you have to be quite careful about scoping. You can declare variables as local. By default they are declared as global, so be aware of that. Also they are case sensitive, so a here is different to a here. Capital A is different to lowercase a, and if you use I quite often will have variables such as train at signal equals something, but if somewhere down in my code I accidentally missed the capitalization out, that code will merrily execute. It won't flag any errors, I won't get any warnings or anything, but it won't work properly because I've now got 2 completely separate variables, one with a capital A for at, one with a lowercase a for at, and because variables don't have to be declared, the LUA will happily accept that, and I can then spend, a coffee break trying to work out why my code's not working. So be aware of scoping, beware of capitalization, and beware that there's no checking in terms of declaring variables and the such. Also, the other issue on scoping is for loop. So if I have a for loop for I and B in pairs lists, so if I have a for loop like that, the loop variables, and I can explain all of this in subsequent tutorials, so if you haven't got a clue what I'm going on about, hopefully I can explain these better in subsequent videos, but for the time being I'm just trying to give a quick overview of some of the issues to those that are familiar already with programming, and in a second I'll get on to the EEP specific things that I wanted to cover. But just briefly before I do that, these loop variables only have scope. They only exist within this loop. So I can use them within the loop. I can say x equals v, but if I try and do that outside the loop, it's invalid. V no longer exists. So within LUA there are a few basic issues that need to be taken care of. You can put whatever you like outside the function calls, so I can have print statements such as the one that comes as standard within the EEP standard script. I can initialize global variables to be whatever I want, and I can put that outside any function declaration. Anything outside the function declarations will just execute once when the program first initializes. So all of this stuff here will execute once upon initialization. So this is from the default script that EEP gives you, so it just gives a welcoming message. What I prefer to do is, for my global variables that I want to use, I'll put them in a dedicated initialization routine, and I'll call that once from the main loop. This main loop has to be there. You have to have a function called EEP main, and it has to return a 1 value. So EEP requires that to be there. You can have whatever other functions you want, but that has to exist, and EEP will then call that routine, that function, 5 times a second. So every 200 milliseconds it will call it. Obviously you've got to try and take care that you don't end up with infinite loops or code bugs that will exceed that 200 millisecond window. In my control program, I actually do exceed the 200 milliseconds. EEP nicely buffers the calls so it doesn't fall over in a big heap, but generally you should be aware that this will get called every 200 milliseconds, 5 times a second, and whatever's in there will execute. One other thing is a particular feature of EEP is you can return as many variables as you want. So here I can say I want to return A, B, C, and then if I use that function, so I can say X, Y, and Z are set with my function whatever. So you can actually have multiple assignment taking place within one line, and a single function can return multiple values, which is quite useful sometimes. Little feature of EEP, of LUA. I keep getting the two acronyms mixed up. Anyway, so that's all I really at this stage want to say about LUA itself. It's a fairly simple language. I don't think it takes very long to learn it, probably even for a beginner. I will try and do a set of tutorials. What I want to do now is just to give a very brief introduction to show it working within EEP. So what I'm going to do is just switch into 2D mode, and I will add a few signals. So let's put 2 signals up here, 2 signals up here. I like to be neat, so let's move the distance markers a little bit out from each of those signals, like so. So if I right click one of these, if I select these signals and I want to add a vehicle contact. So again, in the signals section on the toolbox, select vehicle and click, and you can place a contact. If you right click the contact, you'll get its properties box up, and even without any LUA programming, so no code at all, not going near any programming whatsoever, you can do an awful lot within these vehicle contacts. So you can change signals, you can operate movable elements to models, you can uncouple, you can sound the horn, you can reverse, you can change the speed. So you can do an awful lot from a vehicle contact with no code whatsoever. But this is all about using LUA within EEP, so I'm not going to fiddle with any of those settings. In my LUA code, I have a function here which is called train contact 1. What I'm going to do is, with my vehicle contact, you can set which direction it's active. So for example, direction 1 for this contact is a train going from left to right. You can also say whether you want the contact triggered as the end of the train passes. So by default, it will be as soon as the front of the train passes this contact point, it will trigger the contact. If you select end of train, it will wait until the whole train has passed this contact point, and as the end of the train passes it, it will trigger the contact. It will only trigger it in that direction marked. It won't trigger at all for a train coming from right to left. So having set that up, there's a box here called LUA function. I can put the name of my LUA function in there, and that's all I need to do. Now, when a train passes this contact, it will trigger and execute my train contact 1. It's that simple. This is in addition to EEP every 200 milliseconds executing function EEP main. So there are two primary ways for EEP and your LUA program to interact. One is this 200 millisecond execution of your EEP main program, and then also you can create your own functions which you can call whenever contacts are triggered. Now in this train contact 1, all I've got is two function calls to EEP functions called EEP set signal. That has two parameters. Again, I can cover this in more detail in a later video, later tutorial, but the first parameter is the ID of the signal. So this is signal 1. So here I am changing signal 1, and I'm changing it to a value 2. I'm also changing signal 3 to value 1. So just to explain what that does, there is signal 1. Deselect and move. Here is signal 3. So what I want to do is, as the train passes, I want to set this one to halt, and because this section of track around this loop should now be clear, I want to open that and make it clear to allow another train to come in and pass that signal. There is one slight annoyance, which is some signals if you program a value of 2 to that signal, it will set danger. However, some signals, if you program a value of 1, it will set danger. I think it's a legacy issue. I hope that in future EEP creates all signals with a consistent set of values, so that we know that if you program value X, it does function Y. I want to know if I program a 2, it always sets danger, irrespective of what signal I've put on. At the moment, that's not the case, and you can tell by if you go and right click on the signal where it says select signal aspect, there's a little drop down that has a list of possible states for the signal. That represents the values that you program from the LUA code. So the first value will be what you get if you program a 1. The second value is what you get if you program a value 2. Unfortunately, some signals, danger's there and clear's there. So the only safe way I've found of checking is to go to the actual signal and right click, look at the properties. Really, they should have all been created so that the same value had the same function. I think they should change that for the legacy signals as well, but certainly in the future everything should be consistent. There are some signals with multiple states, so you can potentially have a range of different values. Anyway, very simply, that's it. You have your signal, vehicle contact calls a LUA function, and in this example all I'm doing is setting one signal to danger and clearing another signal. In 3D mode I can actually, if I go into the edit feature, I can select that contact, selected the track, select that contact and copy it. So I can put a copy over there. It's not cooperating very nicely. There we go, and just edit that so that it reads train contact 2, and then also copy it down to the third signal and just edit that so that it calls function train contact 3. And that's it. I've now got a working little loop where the LUA code is operating the signals for me without me having to do anything. And if I just set this train off, as it passes that signal, it will set it to danger if I've got my values right, and as it passes the third signal, it will set the third signal to danger and it will clear the second signal. There we go. Similarly, as it passes, that's previously set, so I'll just clear it as it comes up. So that's it working. A major issue, I think, within the current LUA interface is the fact that you have to create a different function name for every contact. What it needs to do is in your vehicle contact, instead of just calling the function name, you actually want it to pass a set of properties, for example, a set of parameters. So ideally, when I call my function, I want to pass it the train name and the signal number. So what I ideally want is to be able to define the function a full function declaration of what I want to call within this box here. If I do that at the moment, it will create an error. But that is desperately needed. There is some clever, nice person has created a one-line hack with some very clever little code that manipulates the LUA global environment in order to stop that EEP syntax checking, and basically it overrides that and allows you to call a LUA function from this contact properties page with a couple of, with a set of variables that you can pass. So you can pass the train name, you can pass the signal number, and when you click OK, it won't come up with an error message. If you look on the forums, there is that one-line hack. It's quite safe. It's one line of clever code that just suppresses the inbuilt syntax checking and uses the LUA global environment to allow you to do that. What it then means is, instead of having 3 functions here, I would be able to just declare one function and say train passed. I can have my first parameter as the train name and my second as the signal ID, and oops, I didn't want to do that, so sorry, just typing that again. So train at train name comma ID, and if I just copy this code, what I would then have is I could say I want to set the signal whose ID is the parameter that I've passed, and I want to set that to halt, and then I can have some control logic within my code to work out what signal I want to clear. It could be something simple like the ID, something like that, to say this is the ID of the signal I want to clear, this is the one I want to set to halt, and that would then replace all 3 of those functions, one where you have individual functions for each signal. If you've got a layout with 100 signals or something, obviously that's much better, and EEP needs to do that as an inherent feature rather than relying on a one-line hack from somebody. But that one-line hack at the moment makes a huge difference. And basically all you have to do is find the code on the forums, copy it into here. The first time it runs, it overrides the EEP syntax checking, and then allows you to, from the vehicle contacts or other contacts, to directly call an EEP function with multiple parameters, which is great. So anyway, that aside, I hope this has given you a very quick introduction to LUA programming within EEP. We've not gone into anything in any depth, but if you would like to leave some comments, I'd appreciate some sort of guidance as to what sort of things you'd like covered in any future tutorials, what sort of depth you'd like them covered. I don't intend to give a computer programming course, but I have thought about doing some tutorial videos to help with LUA programming, even if you've got fairly sort of basic computer science skills. So leave me some comments and I will try to do those videos at some stage. And in the meantime, thanks for watching this video. Thanks, and perhaps see you soon.